Today, we're going to be doing an extensive data analysis end-to-end project in Python using the Titanic dataset, and this is all going to be coming to you live. So first of all, you're going to want to open Jupyter Notebook. Now I'm going to right-click, open in Terminal, and then type Jupyter Notebook. Now, if you're not familiar with Python for data analysis, machine learning, visualization, or even setting up a Jupyter Notebook environment, I cover all of that on my store. You can find that here at tobygeeson.com. We have workbooks that have helped over 50,000 people reach their dream jobs and goals. Let's head down here, and here you go. If you're an absolute beginner, start here. Although I'd really recommend this one here for pandas, and each of these will come with the notebook and also a detailed guide on setting up your Python environment. But without further ado, let's get right into it. So I have already created this notebook for you. Let's open that up. You can do so just by double clicking it. And I've written out the entire code, so I'm just going to walk you through line by line, running each section of this script and explaining exactly how it works. So first of all, we want to import our libraries. Now, the way Python works, particularly in data analysis, are there a series of libraries that you need to bring into your Python environment to begin the analysis. Now, when you first use these, you're going to want to open up a new cell and type pip install. This is what you can write in your terminal. If you're inside Jupyter Notebook, start it with an exclamation mark. And then type the name of the library you want to install. So here we'll type pandas. To run it, I can do Shift Enter, or additionally at the top of the page there's a run button here. Now for me, it's going to say requirement already satisfied. That's because I already have pandas and I've used it extensively. You can see that here. So what I'll do is just delete that cell. Now let's go to the top and walk through it step by step. In fact, it may be even easier and enable you to follow along if I create an entirely new workbook. So let's hit this button here, or go to File, New, Notebook, and we'll run each step. So first of all, importing the libraries. Now, pandas, as you just saw, is a data frame manipulation library. It's used extensively for data cleaning, manipulation, and also partly for visualization. However, to visualize and plot, I prefer to use matplotlib. And to build on that, there's an additional statistical plotting package for like heat maps and otherwise called Seaborn. So let's import these three libraries. These are the core libraries you're going to want to use. Again, Shift and Enter. It'll take a second and then it will have run. If you're curious, this number up here is just how many times that cell has been run. So if I run it again, it will go to 2 and again 3. So next, let's get these libraries because this is where it gets slightly more complex. I'm not actually entirely sure we use this library. We'll leave it here for now. So these libraries are here, all for machine learning. This is the advanced proportion of this analysis project. You don't need to get to that stage. You could just stick with those first 3 imports. But I wanted to give you an idea of the kind of things we teach on my store. So let's bring these all in. Now, logistic regression is a type of machine learning algorithm. It is used for classification problems, saying something is one thing or the other. Train test split is a key concept in machine learning, training your data and then testing it, seeing how well it did. We then want to evaluate with various metrics to see how well our model was performing, and we can see that here. Additionally, we've got a standard scaler. That just means our data is all normalized and scaled, so it's on the same scale and frame, and there won't be any outliers. So let's hit run here. Now we have all the imports, and again, skipping this one for now, we can get directly into loading the data. Here we'll use a very famous dataset called the Titanic dataset. Now, let's bring this in here. Typically, if you want to use a dataset, say from an Excel file on your computer, you would assign it to a variable, here df or data frame, and say is equal to pandas, which is pd, dot read Excel, and then the name of the file inside curly brackets. Now, we're not bringing it in from an Excel file. In fact, we're going to bring it in directly from Seaborn. Now, Seaborn, as I mentioned, is a statistical plotting library, but it also has many different data sets that you can use to practice on, such as tips, which we went through last time. Let's hit run. Now, I'm going to want to take a little look at this data set to make sure I understand it. So I referred to it with the variable name df. So if I run df.head, which is a method in pandas, and then shift enter, here we go. I can see the first 5 rows, remembering that indexing starts at 0, so it's 0, 1, 2, 3, 4, or 5 rows. Now, the columns we have about all the people who embarked on a journey, the class they were in, the gender, whether they're male, were they alone, did they survive or not. People commonly use this to predict whether they would have survived in the Titanic. In fact, I have my own full video on that. For a little bit more context, I'm going to type df.shape. Now, this is going to tell me how many rows and columns that there are. I can see there are 891 rows and 15 columns. So it's a good sized data set to have a play around with and work on. You can see I did that here. df.info is brilliant. The first stage of what we want to do here is just exploring the data set. So we want to see, are there any null values and what the data types might be. So let's shift enter. And we can see for each of these columns, of which there are 15, and we know that up here, remembering indexing starts at 0. For these columns, which we saw in the head, these are how many null values there are. There are a total of 891 rows. So if there are 891 no values, that means non-null values, that means none of them are null. Null means missing, i.e. it's not there. Then you have the data types. Float is a decimal point. Integer is a whole number. And then you have categories, objects, and booleans. So I wouldn't worry about those too much. Again, we cover all of that on the website. But boolean is effectively if something's true or false. It's one thing or the other. Now, let's continue. So now that we've explored this, I can see there actually are some null values, particularly in some of these columns, like in dec and in age. So let's see how I handle that. You see, we come onto that there. What I actually did here is, let me just jump ahead of myself, is we looked at the null values, but it's a little hard to read. As you can see, and you may be thinking, brilliant, do I have to subtract each of these from 891? No, you don't. You can get the total number of null values overall like this. So now you can see, yes, dec has 688, embark only has 2, and age has 177. Now, in data science and data analysis, there are different ways you can deal with null values. One way is to impute them, i.e. put in a mean or an average, or even put in the value that you know should be there, or just remove them altogether. Let's go back on ourselves and df.describe. This will give us the summary statistics of each of the numerical columns. So we can see the average age very quickly, we can see is 30 years old, rounding up from 29.6. The average fair price was 32. And then we could see the standard deviation from this, the minimum and the maximum as well. So let's go up here. You can see there may be some data issues in here as well. Minimum age being 0.42 doesn't make too much sense. Perhaps they were an infant. And these are done in years. That could make sense. Again, I don't have the domain context on this data set to know that for sure. Vmax is 80 years old. Now, we've run this. So let's handle those missing values. So what I want to do here is actually use pandas for that, manipulating the data frame. As I said, it's really good for that kind of thing. So to handle the missing values, say in the age column, I'm going to impute it with the mean. Now, this here, and I'm going to walk you through step by step because I know this is getting a little bit more complex now. df age, all we're doing here is calling the age column. So you can see if I run it, it will show you some of the values and their index. We know how many rows there are. Now I can call different methods of this. I can write .value counts like this, which is effectively what we just saw. I can see the mean value, which is 29. I can see the median value, which is 28. Now what I could do is let's go back here, fill NA, and I'm filling the NA with the median of age. Then I'm calling after a comma, but still within the curly brackets, in place true. Let me hit run. It'll look like nothing really happened. The reason I'm running in place true is that means each time I run this, it will always be the case. I.e., if I didn't have that here, it would only have made that change within this cell. In place true means it's made that change across the board, no matter what cell I'm playing in. So that's good. We want that to be the case. We want it to stay like that. Now, we want to drop rows with missing embarked values, just because that's something we're going to use later, so it is important to us. And following that, I just want to verify that the missing values have been handled correctly. So let's just get back to this other method here. It's another way of handling it. Rather than just calling the column first, you're just saying I want to drop in the subset here and in place equals true. Now let's just double check that all of this has gone through correctly. You can see when I created this Jupyter Notebook environment, I've already run all of this, so I know that it works. But I just wanted to go through it with you to show you why it works. Okay, so running that cell there, you can see there are still null values in the deck column, but the other ones have gone. I could impute these rows, but I'm going to leave them. I don't know what should go in there, and I don't want to drop rows that have those missing values in deck because it's a lot. It's 688, which is a very large proportion of the number of rows we have. So now that that's done, we're going to get into some feature engineering. I want to create a new feature, family size. Now let's just run this really quickly. Feature engineering is a really important element of machine learning. It allows you to create new columns and manipulate columns that are there. So if we look at family size, what it contains is the number of people in the family, and sibling and spouse as well is the same thing, except it's 1 or 0 here. Now, if we add family size, or we create the column family size, because at the moment it doesn't exist, and set that equal to these two columns added together with an additional 1, then we look at the family size column, you can see now we have a new column. That may or may not be something we actually want to use in our analysis. I just thought it would be interesting to show you generally what feature engineering is. So we break down projects into multiple stages, including data cleaning, exploratory data analysis, we've done both of those, and then feature engineering, if needed, excuse me. So let's create another feature, is alone. And we're going to assign that to an integer. Once we've done that, we're going to go a step further and convert the categorical variables into numeric. Now, what does that mean? Well, what that means is we have sex, right? That is their gender. Are they male or female? Is what's in this data set. We want to assign that using a dictionary to 0 or 1. Same as embarked. We want to map using the map method here. C to 0, Q to 1, and S to 2. Now, why are we doing that? It's a good question. Now, computers, if you look at it this way, aren't great at understanding text, but they're very good at understanding numbers. They can quickly see, well, if I know C is 0, I can quickly look at how many zeros there are and factor that in. It just makes it a lot easier computationally on the model to convert them into numeric values. And now all of that is done, we can get into the real machine learning. So first of all, what we're going to want to do is bear in mind that in machine learning, there are two variables, X and y. X we typically capitalize, it's just convention, and y is lowercase. X are the features and y is the target variable. What does that mean? Well, quite simply, all it means is we're going to use X, all of these factors here, all of these columns or variables, to predict Y. We're going to see how much of an effect each of these age, fair, sex, embarked, and so on have on survived. So that if we put in new values and we say, well, I'm 23, I paid 30 quid, and I'm a male, would have I survived? Yes or no? Make sense? If not, don't worry too much. Again, each of these elements are just putting together various things from my course, and this is the machine learning bit very quickly. So we're going to assign X to these columns using 2 square brackets because it's a list of them here. Let's go over here and just hit run. Now with these cells here, you'll see it'll look like nothing's happened. It has run, as you can see here, and we've been through that earlier. Then we're going to scale them, which we touched on lightly at the beginning. Particularly, we're going to scale these features which we're interested in, the X features that we want to use to predict the target variable. The scalar we're going to use is just a standard scalar, so we'll just assign that to scalar. And the X column is going to be scaled and called X scaled. Again, a little confusing, but I wouldn't worry about it too much. Then we get into splitting the data, which is that train test split import, which we spoke out at the very beginning about. So the way you write this is a little bit funny. You write it in a string like this: X train, X test, Y train, Y test, starting with the X's and then the Y's, going train test, train test. Effectively, X train, X test, Y train, Y test is equal to the train test split. And that's going to take in our 2 variables here. If you hadn't scaled it, you would just write X, comma, Y, but we have. So we're going to write X scaled, comma, Y. And then set a few parameters. So our test size is 0.2, aka 20%, meaning we want to dedicate 20% of the data, which we looked at earlier in this Titanic dataset, to actually testing how well our model performed. We want the majority to go to training it. And then we set something called a random state. The number here is arbitrary. You can have any number. We've just put 42 because why not? Now, what this means is each time you run it, it's going to generate the exact same results down to the decimal point every single time based on this state. It's not something you need. The only reason I've put it there is so that you can follow along. And that if you run this exactly how I've run it, you'll get the very same results. So let's copy this into here and again hit run. Remembering you could do shift and enter, or you could go all the way to the top, which takes a little longer, and hit run there. Fantastic. Now you can see I got an error. That's because I didn't actually paste in this bit here. So what it's saying is you don't have any X scale data, which is fine. Let's create with this plus button here a new cell, run that, and then rerun this cell, and we'll have no problem. Brilliant. So now that that's done, and we also have this train test data, let's get to actually training the model, making predictions on it, evaluating it, and then visualizing our results. So to train the logistic regression model, very simple. Similar to how we initialized the standard scalar, we initialize the model by saying what model we want to use, which we imported earlier, logistic regression, and setting it equal to the variable model. Then we fit logistic regression, or model, with model.fit to the train data from both X and Y, because we're training it. We're not testing it, we're just training it. We want to initialize the model and then train it. So let's do that. Let's paste this in here. You'll get this here. This has shown you that it's successfully run, and that means you have successfully just trained, created, explored, cleaned, and soon visualized a whole data set. Fantastic. Well, what do we want to do now? Well, the whole reason of it being here was so that we can make a prediction. So let's do that. We want our prediction on the Y feature, or the Y variable, the target variable, to be Y predict using the model to predict on the X test. What we can do now is effectively we've just stored the prediction under the variable yPredict, predicting on the test data of the X features. What we can then do is evaluate how well it performed. Now, we're going to do a classification report on the Y test and Y predict, and a confusion matrix on the Y test and Y predict. So let's do this here. And then all we're doing is calling those variables inside a print statement, just so we can see the result. Now, this shouldn't take too long. With some models, and you can see that was instantaneous. In some models, such as, let's say, a random forest where there's a bunch of decision trees running simultaneously, it can take a very long time to get it done. But this was very quick. We can see for each of the different outcomes, 0 and 1, which is of course relating to our survived, so died or survived, how well it could precisely measure these and how many times there were false positives or false negatives. That's what this is down here. Now, another top tip I have for you is you can actually very easily go online and just Google how to read a classification report, how to understand what a recall is. If you want to take it a step further, as you well know, there's a lot of amazing AI tools out there right now, LLMs, chatbots that you can paste in this entire script into and the results and say, based on the context of this script, interpret the results. Which is amazing. It wasn't something you were previously not easily able to do, and now you can. So stuff like ChatGPT, which you've heard it for years now, Bard, Gemini, Claude is another brilliant one. They're all great for stuff like that. They're also great for testing yourself. You can ask it to question you and quiz you on this data set. But anyway, now that we've done that, and in fact I encourage you to go away and do this, let's then do some data visualizations. So I want to plot the distributions of passengers by age. Then I want to plot the survival rate by class, and then we'll plot survival rate by gender, family size. We'll create a correlation matrix using Seaborn, and then we'll plot the heat map. Now, this is something important to note here. Inside Jupyter Notebook, you don't have to write plt.show because it can actually run in the cell. You can see the visualizations in line. As you can see down here, let's scroll all the way to the bottom. There you go. That's not the case in all Python environments, in all IDEs. So sometimes you'll have to write that, which is why I've left it there, just in case you're not using a Jupyter Notebook. It won't make any difference running it in Jupyter Notebook, so we'll leave it. But typically you'd write it as the final line after each of these visualizations. Okay, so in fact, I'm going to copy all of these in just to take up as quick time as possible. And we're going to run through each of them. So the way you create a visualization, the way you do statistical plotting in Python is as such. So here we'll be using a combination of matplotlib, which we assign to PLT, and Seaborn, which we assign to SNS, which again is just convention. What we'll do is set the figure size. You don't have to do that, but otherwise it can be quite squished or too big, often just not the right size at all. So we're specifically saying I want it 10 by 6. That's usually quite a good size. Then we call the type of plot we want to do. Here I'm doing a Seaborn hisplot. Here a bar plot. Here a bar plot as well. And then what columns we want to be plotted. So here I want in the data frame the age column. Being a histoplot, it's a histogram plot. It's a bit like a bar plot, but it puts stuff into various bins or groups. Here we're putting groups of 30 by age. And then KDE is true. That's just the line that goes across like this. In fact, I can show you up here. That's the great thing about Python, is how customizable it is. You don't have to assign it to true, but let's go to the top. That's this line here, just to give you a good idea. Then we're labeling the axis. We want the x-axis to say age, which is this one here, and the y-axis to be frequency. In fact, I believe we also set a title as well. with plt.title, and here we then put in side quotation marks, we want to assign it to distribution by age. And then we just repeat that process, setting the figure size, the plot type, which columns we want to look at, and where the data is coming from, the data frame. We want a bar plot, this figure size, looking at the x-axis being family size and the y being survived. Then we'll just label it. The only one that's a little bit different is this correlation matrix. So we want to look at the numerical columns with df.core, and then we wrote numeric only is true. You don't have to do that, it's just how we wanted to approach it. But once you've done that, you can very similarly then just plot it like we have before. Doing the figure size, I'll delete this as you know it's not necessary. Doing a heat map and not equals true, that annotates it with the values. And setting the C map, the color map, which we want cool warm, which goes from blue to red, saying how much they are correlated. And then we're just going to center it. So let's hit run. And this might take a moment. You can see it running through here. Now, if we press this, there we go, we can just expand it and we can go through each of these, seeing the distribution of passengers by age. The majority of them were 30 years old, max of 30 and lowest of 0. Survival rate by class, as you know, first class survived the most, which is the unfortunate truth of the Titanic. And it goes down very linearly, like this, from third, second, and first. We also know gender. Gender 1 survived the most. Now, what did we assign 1 to? Well, we did that with the dictionary up here, so we can actually confirm that. Female was 1. Male was 0. So females survived a lot more than males, which is again what we expected just with our context of the Titanic, if you've looked into it. Then family size. You see, interestingly, it goes up. So the more members of your family, the more you survived, but then it significantly drops to below even just 1 person when you have 5. Although it starts to crawl back up again. And there's no data for 8 or 11. So that's really interesting, and it shows you here how data can tell a story. Now, the way you read this correlation heat map is to see that everything is 100% correlated with itself. See survival here, go down, and survival, which makes sense here and here, and then looking at fair and fair. But looking at the colors and the values, say in survived, but with P class, you can see they're quite blue, they're a negative value, they're not really correlated. In fact, this one really isn't. This is survived, doesn't really have any relationship between this field or column here. Something that seems to be one of the stronger ones is survived and sex. As we know, we've seen that in our visualization, being a female does mean you have much higher odds of surviving. Now, if you've enjoyed this video and if you've got any value from it, I definitely highly recommend checking out my website here. There's a lot of great stuff on there. If not, we've got all the content on YouTube too over at Toby's Data Digest. Now, thank you very much for watching and all the best.